All right, so let's go ahead and get started. If any of you notice that that goes away, that means that my computer's RAM has crashed. So I need to restart the recording. So if you notice, let me know. If not, it's not a big deal, but I'm also going to try to keep my eye on it. Okay, so the first thing that we're going to do today is we're actually going to do a problem to give us some more clarity in terms of accounting profit and economic profit. So, firstly, we are going to be doing question. Come on. Question 8. So we'll do question 8 first. So this is 8 from your book in page. Doesn't give me a page. The conceptual and computational questions section. So this is in chapter 1, conceptual and computational questions. And we're going to be solving number 8. All right, so what does number 8 ask? Well, number 8 asks us, it says, so we're told Janet spends $30,000 a year on supplies, on painting supplies. She recently received 2 job offers from a famous marketing firm. Oh, this is interesting English. It should have been famous marketing firms. Right now it reads from a famous marketing firm. Why would the same marketing firm give you 2 possible jobs, one at 110,000 and the other 80,000? So there's a typo in the book. So she's told that she can either take a job for 110,000 a year, or she can take a job for 80,000 a year. So she could choose to work, and this is how much she would make. So what are these amounts? The implicit cost, the opportunity cost. And what do? Do we sum them up?
What?
Do we sum them up? Do we add them together to get the total implicit or opportunity cost?
With the explicit plus implicit equals opportunity, right?
Correct. Yep, the explicit. So she's talking about how when we talk about the economic profit, it's going to be equal to the revenue minus the implicit plus the explicit. Right? Where explicit we're using here to be things that we have actually paid. We wrote a check, we gave them cash, we charged it on our credit card, right? Implicit is the opportunity cost. It's what we gave up in order to do this thing. So if Janet is giving up these job offers, what's her implicit cost or what's her opportunity cost?
I mean, are we going to do this whole thing under one, or are we going to do like 2 different cuts, like 110 and then take 80,000 separately, or are we going to add them? Okay.
Nope. So great question. So what we're actually doing, this amount here doesn't matter. Period. Because it's the next best opportunity. It's not the combination of all of your next best opportunities. She can't work both those jobs at the same time, right? She can't take the $110,000 job and also take the $80,000 job. So whatever one is the best, and in this case, more money is better, right? So the one that's higher income is going to be the best. So this is going to be her implicit cost, aka the opportunity cost. And so we've got one half of the equation, right? We're also given some more information that's going to help us fill out this revenue bit. We need to figure out what's going on with revenue, right? So we're told that she estimates that she's going to sell 25 paintings and she's going to charge $8,000. And so in order to get our revenue, we're going to need to multiply the quantity and the price, right? Quantity times price is going to equal my total revenue. Pardon?
200,000.
Thank you. So my total revenue is 200,000. Now we're asked in part A, we're asked what is the accounting profit? And so this is simply just the difference between my revenue minus my explicit costs. Exactly. So it's going to be 200,000 minus my explicit costs, 30,000, which gives me $170,000 as my accounting profit. Does that make sense to everybody? Now, our economic profit, we know, is always going to be less than our accounting profit. So our economic profit is our revenue minus the explicit minus the implicit costs, what she's giving up. And so this is going to be 200,000 minus 30,000 minus 110,000. So this is going to be 60,000. So what is this telling us? This is telling us that, this is the best use of JNet's time. That JNet is recouping that opportunity cost, right? She's getting that 110,000 that she's giving up, and she's getting $60,000 above and beyond that. So we would say that she's enjoying abnormal economic profits. Questions on this? Okay, we're going to come back to this in a second. We're going to jump back into notes real quick, and then we're going to come back to this once we talk about how to adjust things from future values to present values. All right, so back to notes. So picking up where we left off, one of the really important things that we have to remember in economics is that everything is based around profits, like I said before, right? Profits are the big signal, but also about incentives, right? We need to understand incentives. And so relating to those profits, right? A change in profits provides an incentive to resource holders or stakeholders, you might hear them called stakeholders as well, to alter their production process, right? Their use of resources. If all of a sudden, the price of, I don't know, I'm trying to think. If like the price of wheat goes up or something, right, then everybody's going to change their farmland from producing corn to producing wheat. So if the profits, if it's more profitable, then you're going to switch your resources so that you can enjoy more profits, right? So the profits are the incentive for those stakeholders, those resource holders, to switch what they're doing. And maybe they're making shoes, and all of a sudden, it's summertime and everybody wants sandals, right? So they have to retool in order to make sandals. Or maybe they're making, this actually happened with the whole toilet paper shortage, right, at the beginning of COVID. And the reason why is because there's like two different production types of toilet paper, right? There's like the toilet paper that's like the industrial grade toilet paper that's like in the restrooms here, right? Which is like really thin and crappy, you know, and then there's the like premium toilet paper that everybody buys. And essentially there was like, you know, 60% of all the pulp was going to here and 40% was going to here, right? And then when we all stopped going to work stopped buying that crappy toilet paper, and we realized like, oh, all the kids are going to be home from school, right? And so then we went ahead and bought extra toilet paper because of the fact that just there would be a greater demand on toilet paper in our household. And the companies that were producing that, you know, higher quality of toilet paper didn't have enough productive capacity. And so what ended up happening is a lot of those factories that were producing those giant rolls of toilet paper that are the industrial size switched their factory, right? They altered how they use their resources. They altered the technology that they were using in order to produce more of the consumer grade toilet paper, given that it wasn't just this temporary blip. Once they realized like, oh, this isn't just going to like go away in a couple weeks, they started to retool things. So that is leading into our next point, that within a firm, the incentives really drive both how the resources are used and how productive the workers are. So, you know, as a manager, one of your roles is to construct incentives that are going to induce the maximum amount of effort from your employees. And so we will revisit this when we talk about different types of monitoring and different types of discipline and so on and so forth, different types of incentives in the workplace. So we've got to understand incentives in order to understand managerial economics. What else do we need to understand? We need to understand markets. Which is why chapter 2 is like just almost entirely a review of any economics class that you've taken. It's just like, okay, remember supply, here's the factors that determine it, here's how it changes. Remember demand, here's the factors that determine it, here's how it changes, right? So we're not going to go over a lot of that. I'm going to do a lot of problems because otherwise it's going to be incredibly boring, right? Because have we all taken economics classes? So it might be a little dusty, right? But at the end of the day, you understand that, you know, there's shifts in demand, there's movements along demand curves, so on and so forth. So it's important for us to understand in these markets that there's two sides to every transaction. Right? There's a buyer and a seller. And there's three different types of rivalries. And these determine the bargaining position in economic transactions. So our three types are, we've got a consumer-producer rivalry, we've got a consumer rivalry, and lastly we've got producer rivalry. So some examples of this, right, in terms of producer-producer rivalry, the book uses this example. It's a very good example. Southwest has this policy, right, about 2 check bags free, and so as a result, that's a rivalry with other producers, right? They're saying they're directly competing with other airlines that do charge you for bags, like Spirit and United and all the other things. The flights might be cheaper, but they're going to charge you for bags. They're going to charge you for soda. They're going to charge you for snacks, right? Charge you for a seatbelt. So consumer rivalry, that would be something like where something is really really rare and you have to either line up and get it. So graphics cards right now, right? In terms of like you cannot get any graphics cards or PlayStation 5s, those kind of things. We also have government and the market, right? So the other thing too that's important to keep in mind is the fact that the government shapes the playing field and sets the rules for the market. We didn't talk about this, so real quick. Consumer-producer rivalry is when there's competing interests of consumers and producers. So consumers are attempting to negotiate or lower prices. So, this could be, your phone bill, right? It could be your cable bill, your internet bill, right? A lot of times, you can call and be like, hey, I'm not getting what I think I deserve, and you can kind of talk to them and get a different policy, right? So there's a consumer-producer rivalry between yourself and your phone company. Aha, important part. The time value of money. If I asked you to loan me $500 and I told you I'm going to give it back to you at the end of the semester, probably wouldn't do it, right? Because there's no incentive, right? You don't get anything. You're giving up those $500. That's time that you could have spent enjoying those $500, right? You could have gone out and bought $500 worth of whatever it is that brings you a lot of enjoyment, clothes, movies, entertainment, whatever, right? You could have also invested that $500 and there would have been some sort of return. Now, depending on the market, it's going to be a different return in the small amount of time. But the point being, money that you get in 3 months or 2 years or 5 years or 10 years is worth less than money right now. At the end of the day, money that we get in a year doesn't have the same present value. And so when we get these word problems that talk about how there's a revenue that pays out every single year, well, how do we bring all those future, right? So if we end up paying something right here, and then we get paid here, and then we get paid here, and then we get paid here, how do we bring all these things back to some sort of present value amount? So that's what we're going to be doing in this section here. So let's start off with just the present value of a single future value. So in order to do this, there has to be some sort of prevailing interest rate, or has to be some sort of assumed interest rate. So our formula is as follows. We've got the present value is equal to my future value divided by 1 plus the interest rate exponential power to the exponential power of the number of years or periods. It could be compounded periodically. It's usually compounded annually, but it could be periods. Just the number of, however it's compounded, number of years. Other way of thinking about this is the present value is equal to that future value that we're told minus some opportunity costs of waiting. So that might be the foregone interest, that might be the foregone enjoyment, there might be a risk that you could loan Dr. McCarthy $500 and he could just quit and disappear, right? So, you know, there's an opportunity cost that you need to integrate into these calculations. So the present value, okay, so let's go ahead and do an example here. So if I said, I'm going to give you, $300 in 3 years, what would that be worth right now? So the present value is going to be 300 divided by, and we'll say the interest rate's 2%, 1 plus 0.02 to the third power. So this we can just go ahead and take into Wolfram alpha. If I can connect here. Come on, buddy. My little computer's like, I don't have the RAM. Which is why I'm not using Chrome. Because Chrome would just crash it instantly, right? Chrome's like, give me all your RAM. All right, Wolfram alpha. The nice thing about doing this Wolfram alpha is that we can kind of type it out, and it looks exactly like the way that I wrote it here. So 300 divided by 1. So we'll do math input. 300 divided by 1 plus 0.02 to the third power. Same thing, right? Same thing as what I wrote. So we'll go ahead and press enter. And it gives us $282. Now, when you get these amounts, I want you to gut check it, right? If it's $300 in 3 years, what did I say earlier? I said that the money that you in the future is not worth as much when you bring it to the present, right? If I give you the option of I'll give you $300 tomorrow or I'll give you $300 in 3 years, which one would you rather have? $300 tomorrow, right? So this number should be less than the $300. So it's less than the $300, 282. Awesome. So that's our answer, $282. And some change. Which makes sense, right? Because this is the future value minus some opportunity cost of waiting. What's our opportunity cost of waiting in this particular problem? It's going to be $18. Does that make sense? What if we have a stream of future values, right? Too often it's not just that we have a single future value, but we have multiple future values. We've got $100,000 coming next year, $50,000 coming the second year, another $100,000 coming the third year, right? So how do we get the present value of a stream, a series of future values? I'm glad you asked. Let's go ahead and do it. So this one, we've got a similar equation. So we're going to assume right now that we're just going to have 3 streams, okay? And then after we do an example, then we'll talk about the more general case if there's more than 3. But just to keep it simple, we're just going to do 3 streams, 3 future values. To the 1 plus FV2 over 1 plus I exponent 2 plus FV3 over 1 plus I exponent 3. So let's go ahead and do an example. So if we're told that the interest rate, if the interest rate is 3%, year 1, we're going to get $10,000. Year 2, we're going to get $50,000. And year 3, we're going to get $100,000. So on your own, I want you to plug in the values, and then we'll plug it into Wolfram Alpha altogether. But go ahead and plug in the values. I'm going to freeze the screen. Maybe. Blank? I'll blank the screen, and then I'll solve it. Did you guys need that more? Sorry.
Yes, please.
I thought you were faster. You guys all done? Cool. Did you get this? Awesome. So let's go ahead and put that into the Wolfram Alpha. Now the nice thing about Wolfram Alpha 2 is that I can just copy this. I don't have to retype it. And then I can just change the parts that I need to change. Does that look right? We end up with $148,000, $352.70. And once again, when you guys do these calculations, I want you to run this through your gut check. I want you to, give it the sniff test, right? Does it stink or doesn't? Does it jive? And well, okay, am I going to add up all the future values? 100,000 plus 50,000 plus 10,000 is 160,000. My present value is less than 160,000. That clears my gut check. Any questions on present value? Okay. One more definition, and then we'll do another question from the book. We'll do number 10 in a second. So real quick, we got to talk about net present value. So net present value is just, it's the present value of the income stream minus the current cost of the project. And I'm just going to put in here in parentheses just to save us some confusion, the current one-time cost of the project. It's not an annual cost. And so this definition of net present value is going to be that future value and then the way that we kind of extend this, right? Hopefully this isn't new to you guys, but you just do plus dot 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 and then another plus. And so essentially it's saying, however many need to be in the middle there, FV3 to the third power, FV4 to the fourth power, right? Till you get to the last one, which is FVN over 1 plus I to the N year. And then all of this is going to be subtracting C naught, that initial cost. So if you want, you can think about this as the total revenue minus the total cost. So let's go ahead and jump back into the book and do question 10. So once again, this is in that same conceptual and computational question section as when we did number 8. And this is going to be number 10. And so we're told in number 10 that an owner can lease her building for $150,000 per year for all 3 years. So there's a potential revenue for the building of $150,000 every year for 3 years. We've got explicit costs. They just tell us what the explicit costs are here. Is $50,000. And then we've got implicit costs of $65,000. Everything is received, all of the costs are due at the end of each year. We're told that we have an interest rate of 7%. So we're asked to find the present value of the stream of accounting profits and then economic profits. So let's just first do the accounting profits. So once again, I'm going to go ahead and I'll let you guys get this down, but then I want you to try this on your own. And then we'll take a couple minutes and then we'll all come back together as a group and talk about how we did. Now, the book is not very clear about this, but one of the things that you should be asking, if it was on a test or something like that, like if it was, you could absolutely ask for a clarifying question on it. These explicit costs and implicit costs, these are also every year. So if it doesn't say one-time costs, we're just going to assume that they mean every year. All right, looks like everybody's done. You should have got something like this. So the accounting profit, the present value of the stream of accounting profits is going to be those yearly accounting profits divided by 1 plus the interest rate to whatever that year is, however many years away we're pulling those future values into the present from. So this, again, we can plug it into Wolfram Alpha, but just to save us some time, this ends up being $262,431.60. And so how do we pass this through our sniff test? Well, we can say, okay, every year they're making $100,000. So $100,000 times 3 is $300,000. Is this less than $300,000? Yes, it is. All right, cool. Sounds good. Now go ahead and do it for the stream of economic profits. So if our implicit costs are $65,000 every year, what's our economic profits? All right, so I went ahead and just to save us some time, I didn't write out the full thing, right? But it's the same as before, except now we're including these implicit costs, right? So it's the same as before with just an extra item. 150 minus 50 is 100. 100 minus 65 is 35,000. So that's why I use these $35,000 numbers here, because this is equal to 35,000. So just to save myself some time. And then obviously 1 plus 0.07 is equal to 1.07. So again, just to save myself some time there. And this ends up being $91,851.06 is the economic profit, the present value stream of the economic profits. Questions on that? Economic profit, accounting profit, and how it integrates with present value stuff. Cool, awesome. Great, great, great. Moving right along. What if we had an asset that we expect to generate cash flows forever. How do we get a present value for a cash flow that just generates forever, right? Well, because of the magic of geometry and stuff, right, we're able to actually approximate it. So it's going to be my cash flow that I get at year 0. So we're going to abbreviate this as CF from now on. So CF0 plus my cash flow from year 1 over 1 plus I to the 1 plus my cash flow from year 2 over 1 plus I to the 2nd plus ... plus cash flow n. Oh, actually, there is no cash flow n. We can't do that. There's no last cash flow. So we literally just have to say plus ... just to mean that it just goes on forever. And so the present value of this, if it's the same cash flow, right? If CF1 is equal to CF2 is equal to CF3 and so on and so forth, right? Then there's a nice little shortcut that we can use. So these are called perpetuities. And so the present value of a perpetuity is the easiest formula ever that you'll probably have in this whole class. It's the cash flow divided by that interest rate. The magic of geometric, wow, what do they call it? Geometric distribution? Oh man, I can't, I'm blanking on the word. Series, the magic of geometric series. If the geometric, so the reason why we can actually sum it all up is because at a certain point, 1 plus I to the 100,000 power, right? Let's go ridiculous for a second, right? 1 plus I, like 1.07, let's just do it real quick. So anything to the million power is going to be a really, really large number, right? So let's not use a million because that's too much. But let's just say 100 to the 100 power. Come on, Wolfram. Oh my gosh, it's still crazy big. Just use the 10th power. So just the 10th flow that we have is going to be 282 million. So this is the number on the bottom, right? This is the number on the denominator. So it doesn't matter. Like think about a cash flow of $300 divided by that. It's going to be nothing. It's going to be 0.00000, right? It's going to be to 10 to the negative 6, right? So what ends up happening is the more that we go, the further we go in the series, the smaller the amount gets. See, and at this point, right, even the 7th series, we end up adding 0.00, you know what I mean? So at a certain point, we add stuff that's so small that it no longer increases the total number. So it's called a geometric approximation. It's a cute little trick. So then leads us into, well, this is all great and well and good if we're talking about projects, right? If we're talking about an investment, but this is managerial economics. We're talking about firms a lot of the time, right? So how do we estimate the value of a firm? So that's going to be our next part of today, is how do we estimate the value of a firm? And so the value of a firm, so first we're going to assume no dividends. Do we all know what dividends are? So you own stock. They end up giving you a share of their profits at the end of the year. It's discretionary. They can decide to do it or not. There's a lot of market expectations, right? Some companies, they always issue dividends. Some companies, they rarely issue dividends, and they end up, just reinvesting that money or buying stock back or whatever the case may be. So dividends it's essentially a coupon payment that you would get on stocks. It's the yearly small flow of money that you get, but it's discretionary. So when there's no dividends paid out and there's an expected constant profit growth rate, which is a big assumption, right? This is a kind of heroic assumption. Like who actually exists in a world where they're running their company and there's a flat, you know what I mean? Like you always grow at 3% every single year, no matter. It doesn't happen, right? But it's a construct that we use, and so we are assuming that this growth rate is less than the interest rate. And so for this, our present value formula is going to equal whatever that profit is in year 0. So we often use pi for profit. It's really aggravating because we use pi for way too many things in economics. We also use it for inflation. There's so many Greek letters, right? Use extra ones. I don't know why, but that's what they do. So profit is going to be pi naught, pi 0. And we're going to multiply this by this fraction that's 1 plus the interest rate divided by the interest rate minus the growth rate. So let's go ahead and do an example. Okay, we're going to do number 4. So number 4 tells us that a firm's current profits are $900,000. The profits are expected to grow indefinitely at a constant rate of 2%. If the firm's opportunity cost for funds, what does that also mean? The opportunity cost for funds. When we hear that phrase, that is an equivalent phrase of interest rate. So we're given an interest rate of 4%. We're asked in A, what is the value of the firm if it gives no profits as dividends? So once again, I will give you a couple minutes, our last couple minutes, and we will pick up in class on Monday talking about the present value of firms without dividends. And this would be the only Friday that you don't have an activity that you're supposed to do for Monday's class. So usually you'll have a case study, you'll have something else that you're supposed to do during that time on Friday, and I'll have you turn it in or we'll discuss it on Monday, and that'll be your attendance grade for Friday. So our present value for firm, we're literally just going to plug all these things into the formula up here, right? And so we've got the profit going right here, we've got the growth rate going right here, and we've got the interest rate going 2 different places. So we end up with 900,000 times 1 plus 0.04 over 0.04 minus 0.02. Which ends up giving us, oh, that's right, I forgot that the book didn't have this updated. So, we'll have to wolfram it. Oh, let's just get rid of everything. 1 plus. Oh, that's right, we should do double parentheses. Divided by 0.04 minus 0.02. And so we end up with $46 million, $46.8 million. All right, any questions there? Awesome, thank you guys so much for a good class. I was able to record the whole thing, so I will throw this up on YouTube, and I'll send a link as an announcement later today, and I will see you all on Monday. Have a great weekend.
Thank you.
Thank you.